Hello, so today we are going to do a review of electric fields and what do they mean. So we're going to relate it back to something we know very well, gravitational field. Okay, so let's say that this is the Earth down here, and we know that close to the Earth, a 1 kilogram block will have a force of about 10 newtons because the force on the block due to the Earth would be the weight is equal to mg, and g is approximately 10. So 1 kilogram times 10 meters per second squared would be 10 newtons. And we know that as we get further and further away from the Earth, the force on that 1 kilogram block will become less and less because the gravity becomes weaker and weaker as we get further and further away from our center of mass of the Earth. So now consider a 3 kilogram block instead of the 1 kilogram. So the force close to the Earth is no longer 10 newtons. Before, up here, it was 5 newtons. So what do you suppose the force on a 3 kilogram block would be if the force on a 1 kilogram block is 5 newtons? That's right. It would be 3 kilograms times the 5 newtons per kilogram. The 5 newtons that the force was on a 1 kilogram block. So the total would be 15 newtons. This 5 newtons per kilogram is what we call a gravitational field strength at this point right here. So at the point close to the surface, our gravitational field strength would be 3 times 10 newtons per kilogram equals 30 newtons. Which number do you suppose is our gravitational field strength? That's right, it's newtons per kilogram. This is how much force this box or object feels at this point due to the Earth. And we happen to use the Earth because that's where we are, but we could use any planet in this case for gravitational field strength. Okay, so what is the gravitational field strength at this point if we have the mass and the force? So go ahead, take your time to solve this, pause the video, and then play it back when you, or press play when you have solved it. Okay, so let's see if you got it correct. So if we have the mass, so the mass times this field strength, I'll just call it x, is equal to our total force. So 5 kilograms times this unknown field strength is what we're trying to find, is 35 newtons. So this field strength is 35 divided by 5, which is 7. Yeah, 7 newtons per kilogram. There we go. Okay, so if we look at the Earth, as we get further and further away from the Earth, the field strength becomes weaker, 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 as you could tell by the lengths of these arrows here. They also get closer together. So closer together the arrows are in a field mapping diagram, the stronger the field. Also, as the vectors get shorter, the field is smaller. So relating this to electric field, F equals QE. So just like force is equal to mass times the gravitational field strength, the force by due to an electric field on a charge is equal to the force is equal to the charge times the electric field strength. So the electric field is the force that 1 coulomb would feel if it were placed at this location. Q is not the charge that is causing electric field. Just like the earth was, the box was not causing the gravitational field, the earth was at the location of the box. Okay, so this is old stuff for you, and we've done this example.